All right, welcome to the review for the test tomorrow. So, tomorrow's test is going to be open book, open notes, so you can use anything you want to go through it. I'm just going to try and help you figure out what you need to know, what you should be really looking at, and being ready to be able to identify during the test. So, hopefully we won't be doing too long of a recording here, and it won't take you too long to walk through all this, but I want to go through some examples also, just to help you out and give you an idea of what you're supposed to be doing. So, I do want you to know some vocabulary. So go back through, maybe look through some of the vocabulary. You can also look through it during the test. You can use your book, you can use your notes. I would write down some of this stuff though. So, remember, a transformation is an operation that maps an original geometric figure. So everything that we've done so far, they're all transformations. Reflections, transformations, rotations, and dilations. Those are all different types of transformations. So you're going to want to know that. The pre-image is before. That's your original shape. Your new image is just called your image. The second one, the one you're drawing, the one you're reflecting, rotating, that is your image. So pre-image leads to the new image, which is just called the image. So pre-image to image. And this one's on translations. We know kind of what that is, I hope. So you just move it up and you're up, down, right, left. You don't do any kind of thing, just moving it up and down a certain amount. Or right and left. So, another thing, congruent. Same shape, same size. All the dimensions are the same. That's congruent. I'm not going to go through all this. I do also want you to remember the rule, the translation rule, how they write that, how they write down when they're doing something. So that is right here. So notice that they do x plus a -2, y plus 1. This means left 2, so x minus 2, y plus 1. That's how you're writing down the translation rule. The translation rule in this problem is x minus 2, or you can write x plus -2, and y plus 1. That's the translation rule. So you're going to move your shape down 2, or sorry, left 2 because it's negative, and up 1. Left 2 because x minus 2, and plus 1 for y, so it's up 1. So work through these a little bit. I'll have some review problems for you to do for all of these. You don't have to do all the review problems. Just do what you think you need to do. Hopefully that'll help you also. Alright, I'm going to go to the guided practice page. If you want to follow along in your book and write down some of this stuff, it's on page 456. So, I'm just going to do one problem. So let's just do this first problem. We have -4, -4. 1, 2, 3, 4. Careful when you're graphing. Make sure you're putting on the right points. I've seen some people make mistakes just graphing it wrong. Putting points in the wrong spot. So double check that on your test before you turn it in. 1, 2, 3, down 1. -3, -1. And 2, 1, 2, -2. Right here. So it's a triangle, so you can just draw your lines in. Mine aren't going to be perfect, but that's alright. And you just take every point and you go 3 units right, 1, 2, 3, and up 4. 1, 2, 3, 4. That is my new point for that part. For this point, which is in y. So this is my y prime. For my x, we go over 3. 1, 2, 3, up 4. 1, 2, 3, 4. My new x right there. And my new z. 1, 2, 3. 1, 2, 3, 4. And that is my new shape. So, that's all we're doing for translations. Up, right. Just try to remember that. That is the first chapter. Hopefully that helps you. Go back through the rules. So if this is this rule for this one, I'll just do that too. So the rule for this one, x, I'm moving 3 units right, so it's addition. If it was left, it'd be subtraction, but it's addition. And my y value is moving 4 units up, so it's y, because it's up, it's positive, so it's plus 4. And that would be my translation rule. So if it's asking you anything like that in the assessment, that's what it's asking about. Anything like that in the test. So, let's go with 6.2 and review some things for that. This is reflections. And I have seen some people, there were a few struggles with this. It wasn't too bad though from what I saw in the homework people doing. We did pretty good on this. So reflection is a mirror image of the original figure. So if it's over the y-axis, it's going to look like this. You're going over the y-axis, and it should be looking like symmetrical. It's going to be like study these images a little bit. Try to get yourself really reminded of what it's supposed to look like over this. It should be symmetrical. Same thing with the x-axis. It's going over the x-axis, and that is your line of reflection. Wherever you're going over, it's only going to be over the y-axis or the x-axis. The y-axis or the x-axis will be your line of reflection. So there can be other ones, but we're only going to work with that. And it'll tell you, so if we looked at this example down here, the image over the x-axis, that means it's your line of reflection. And then they're going over that. So that's kind of what I want you to know. Again, these are transformations. All of these reflections, translations, rotations, dilations, they're all transformations, just different kinds. Let's do an example of this one. So I'll graph the image. 1, 2, 3, 4, 5, 1. Sorry, I kind of lost track. 1, 2, 3, 4, 5, up 1. That's my A value. My B value is 1, up 2. B. And C is over 6. 1, 2, 3, 4, 5, 6, up 2. So that is my shape. And we are reflecting this over the x-axis. So we're going over the x-axis. Now, a cool thing to remember, so notice how this is moving over the x-axis is moving vertically. My x values are all going to be the same if you're looking at this closely. I'm going from here to here. All my x values are going to be the same. So if I'm going over the x-axis, x values stay the same. If I'm going over the y-axis, y values stay the same. And then my y values for this one, if it's the x-axis, my y values become the opposite. So if they were positive, they're going to become negative. If they were negative, they're going to become positive. The same thing can be said when we're working with a reflection over the y-axis. If it's over the y-axis, my x values become opposite. If it's negative, it'll become positive. If it's positive, it'll become negative. Because we're moving horizontally over the y-axis. So all my y values will stay the same over the y-axis. Now, since we're working with the x-axis, they're all going over this x-axis. So I'm 1 up from here, means I got to go 1 down. Same distance from the x-axis. 1, 2 from here, 2 down, 1, 2. And I'm staying on the same x value. So I'm still 6 over for my x value. For this one, I'm still 1 over, 2 up, so I have to go 2 down now. 1, 2. The same distance. So make sure you're keeping track of that. So my B value is still here, B prime. My A prime now is here, and my C prime is here. So if they wanted to just go with the vertex, I really want you to visualize this when you're doing this on the test. You really need to visualize this. If you're visualizing it, it should help you from making mistakes. So if I'm going over the x-axis, x values stay the same. So my A is still going to be 5. My y value, I'm moving vertically over the x-axis, so my y value is going to be opposite, -1. B value, my B, 1 stays the same as my x value, 2 is going to be opposite, so it's -2. C, my x value stays the same, because we're going over the x-axis, and my y value becomes the opposite. So hopefully that makes sense to you, that helps. That's really what I want you to take away from this lesson, is how to reflect it. There's not a whole lot of extra like there was in the transformation, but hopefully that makes sense. Now, rotations. This is probably the most difficult lesson, I would say. And I don't want you to worry about rotating over a vertex. We're only going to focus on origins. So, rotating. Big takeaways. Center of rotation is a fixed point, and that we're going to just work with center of rotations on the origin. And that's really all I'm worried about for this test. So keep that in mind. Just worry about the origin. Don't worry about like this example 1. Don't worry about those. I want you to worry about ones like example 2. And I want you to really focus on remembering these. You really need to know these formulas. So if I'm doing a 90-degree rotation, my x value is going to become my y value. So in here, a was -1. That's a bad example. B was -1, 2, 3, 1. -3, 1. So it's going from -3 as an x. My x value is going to be at the back now. So it's going to be a -3 back here, but it's also the opposite of x. So it's +3 now. It was -3, it changes to a positive and moves to the back. This is only for 90-degree rotations. And my y value comes to the front. So it's 1, 3. Remember this formula. You can use this, like I really would like you to use this during the test, because this is going to really help you. Since it's open book, use this. Use this right here. It'll help you. Write down in here also, this is 270 degrees counterclockwise is the same as this 90-degree rotation. That is super important. You really need to know what the counterclockwise rotations are equal to clockwise. Because now you can just use the same formula if it's 270 degrees counterclockwise as well. And I can promise you something like that will come up. I saw some mistakes on that in the homework. Really focus on that. 270 degrees counterclockwise is 90 degrees clockwise. Now, 180 is the same both ways. Everything just goes to the opposite. So if I had a 3, 3, it'd just be -3, -3. If I had a 5, 4, it'd be -5, -4. 180 degrees, either way, is the same. So everything just becomes the opposite. If it was negative, it becomes positive. If it was positive, it becomes negative. So all of your values will just change opposite. That's all 180 degrees is. And then graph it after you have those. I highly recommend finding your points first, your order pairs first, and then graphing. Don't try to graph it visually. That's when mistakes are happening. So don't do it graphically first. Find your points first. 270 degrees. My x value is going to move to the back. And this time, it's not going to change positive or negatives. My y value changes to the front, and it will be the opposite. So if it was positive, it's going to be negative. If it was negative, it's going to be positive. So for this example, if we did 1, 2, 3, 4, -4, -1, my -4 for x would move to the back, and my -1 would move to the front. But it's the opposite now because y is opposite here. So it'd be +1, -4. So really focus on that. And you can go back and use this. You can use this on the test. Please use this. Try to remember these. Clockwise, counterclockwise. 90 degrees counterclockwise is the same as 270 clockwise. So if you see counterclockwise and you see 90, just go to 270. Just remember, 270 and 90 are interchanging when it's counterclockwise and clockwise. So if you see 90 counterclockwise, oh, it can't be 90 clockwise. It has to be 270 clockwise. If you see 270 counterclockwise, it can't be 270 clockwise as well. It has to be the 90 clockwise. They switch. They just switch. And we always want the clockwise one. That will figure us out with these. We always want it to be the clockwise one. So if you see counterclockwise, immediately just go, okay, I need to change this to clockwise. What is it clockwise? All right, so let's try one. And we're going to do a counterclockwise one because once we have it as clockwise, we can just see how that works too. So 270 counterclockwise. All right, we need to change it to clockwise to figure this out. So 270 counterclockwise is 90 clockwise. So this is a 90-degree clockwise rotation. 90 clockwise. Change it to that immediately. All right, let's look at the points we have. We have 3, -1. And now, don't be afraid to use this. Back here, 90 degrees. X, Y to Y, -X. So we're going to Y, -X. Let's look at our points. 3, -1. Our Y, -X now. So Y is -1. So Y, -X. -1 is our Y, so we're going to have that out in front. Now -X. X is 3. So that means we have to do the opposite of it, so it's -3. That's my first point. My Y point now, we need to make it Y, -X. So, Y is -4. It stays the same because it's just Y. -X. My x is the opposite now. It was a positive, it's got to become a negative now, so it's negative 5. My z, y negative x, again, because it's a 90-degree clockwise rotation. 270 is a 90-degree clockwise rotation if it was counterclockwise. 270 counterclockwise, 90 degrees clockwise. They're the same. So, 1 negative 5. My y value, y negative x now, so y is negative 5, so it's in the front now. Negative x, x. If this was a negative though, remember, we're switching it from the values. So negative x, opposite of what we have, which is 1, so it's negative 1. Now notice, when we're doing rotations around the origin, yes, my values change from positive to negative, but the digits will always be the same. So if I'm going 5 and 1 are my digits in this one, my digits in this ordered pair are still going to be 5 and 1. They can be negative, they can switch spots, but the digits will never change in a rotation. Keep that in mind. Around the origin, the digits never change. So if you find out that you're getting digits that are different, something's wrong. That isn't correct. Make sure your digits don't change. So all we have to do now, we should graph both of them, but I'll graph both of them. 1, 2, 3, negative 1. That's my x value. 1, 2, 3, 4, 5, down 4. There's my y value. This is my original figure. This is my pre-image. Remember, pre-image, and this would be my after image. Z is 1, negative 5, 1, down 5. Draw in my lines now. Ooh, not great drawing in lines. Also, I've been really impressed with some of the art that some people have put into like their reflection, their rotations, and some of the things that they've drawn. It's been really impressive. So, kudos to you on that. All right, let's draw our next image now using the coordinates we found. X, negative 1, negative 3. Negative 1, down 3. That's my x prime. Over 4, 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. Right there. And z is negative 5. 1, 2, 3, 4. Wow, who designed this? This isn't fit. But we'll do our best. Okay, 5, negative 1. So it's going to be right about there. Oh, sorry. That was bad line. Anyway, so this is your image. Just the image, pre-image. Original, after. So, we did a 270 degree. Yes, 270 degree rotation, which would be this way, counterclockwise is this way. So 270 degrees, and we got to here. And it's the same as going 90 degrees to get to here. So, keep that in mind. Those are the same. Those are the big takeaways from this lesson. Hope that makes sense. If it doesn't, rewatch it. Try some problems. Really focus on these. I really want you to focus on these. If you need to take a screenshot, take a screenshot. Anything you can do to remember this thing. So, 180 is always going to be 180. Clockwise, counterclockwise, doesn't matter. 270 and 90, those will change. Those are what I want. Those are the takeaways. These formulas and these interchanging 270 and 90 counterclockwise and clockwise. Those are my takeaways for this one. Dilations. I kind of like dilations. Dilations are pretty cool. They're not terrible. For dilations, let me get there. There we are. For dilations, all we have to do is find our scale factor and multiply that by our values. So whatever x is for my points, multiply that by the scale factor. Whatever y is, multiply that by the scale factor. I don't feel like I have to do a example for this one. These aren't too bad. You're just multiplying whatever the scale factor is that they give you. So hopefully that makes sense. So right here, just look at this. 4 times our x value, 4 times our y value, 4 times our x value, 4 times our y value. You're doing it for every single point that they give you, A, B, and C. So all the points you get, you multiply by your scale factor, and that's what it's going to be. And I know it might be worded a little differently in the test. It might mention about the origin, dilation, about the origin. That just means you're just multiplying it. You're still just doing this. If it's the dilation around the origin or your dilation from the origin or anything like that. Anything that mentions dilation, you're just multiplying by the scale factor. If you see dilation, you multiply by the scale factor. So don't let anything like that confuse you. This is probably what I really want you to focus on. These kind of problems. These ones will be the most difficult from dilation. So, and it's not so much that it's a difficult process, it's more about identifying what's your original and what's your after. Your original and after the dilation. So, your original is always going to be on the bottom. Your after the dilation product or whatever, your scale that grows or however you want to talk about it, the new product is always on top. Original, so new over original. New over original. So let's try one. And that's probably something I would practice if I were you, because that could be confusing. Practice finding the new over original. All right. Mrs. Bowen's homeroom is creating a web page for their school's intranet site. They need to reduce the scanned photograph so it is 720 pixels by 320 pixels. If the scanned photograph is 1080 pixels by 480 pixels, what is the scale factor of the dilation? So, what is the original? The original in this is this one right here. I know it doesn't come first in the word problem, but be careful about that because it's not always the first one that they tell you. So in this one, they need to reduce a scanned photograph so it's this. They're reducing this original photograph to make it this. This is what they want. Whatever you want or whatever you're going to try and get at the end is your new. Your original, the scanned photograph they have already. This is what they have already. So you only actually have to select one of these as long as it's the same. So 720 and 1080, those are in the same spot because they're before the by, and these are in the after spot. So you have to pick one of these groupings. You don't have to do both of them. Both of them will have the same answer. That's a good way to check it though. If you check both of them, that'll make sure your calculations were good. Because if you get the same thing for both of them, that'd be good. So anyway, hang on, I need a calculator. I'll be right back. It shouldn't take me too long. All right, so anyway, original on bottom, new on top. So 720 is my new over 1080. Use a calculator for this, and you can use calculators on the test. So you have 720 divided by 1080, and you get 0.6666666 repeating, which is just 2/3. You can write that as a decimal. That's okay with me. I just prefer fractions because it's more exact. So you're going to have a scale factor of 2/3. And that's really what I want you to take away from the dilations. Yes, you're going to be multiplying them. That's probably the easier part. I trust you on those ones where you just multiply it by it. I think you'll do good on that. I haven't got to grade your new ones, this assignment yet, but I feel like that's something you'll understand. You just multiply it by the scale factor, given your ordered pairs and the scale factor. This is the hard part. This is the hard part right here. So focus on that. 720 is the new over the original. I hope this is helpful. Please let me know how you feel about this. I'm going to give out a bunch of review assignments. You don't have to do all of them. You only have to do what you feel like you need practice on. I'm not going to be grading any of them as an assignment. You can send me things if you want questions answered, and if you feel like you want me to go over them and make sure you're doing them right, I can do that. I'll probably also post answers at some point that you can check through. Just let me know if you have any questions on things. I'll always be there to help. Just let me know. If I don't respond right away, a couple hours, send me another email and make sure I'm getting it. I'm hoping this is all helpful. I hope you feel confident about this test. Open book, open notes. You'll do great. Don't stress about it. I have confidence in everybody. So, yeah, good luck tomorrow, and I hope all of this makes sense and that you're getting some good review with this. Don't be afraid to ask questions. I can always help. So, yeah, just let me know. And if things don't make sense when I answer them, let me know so I can keep trying to help you get to the point you need to be. All right. See you later.